study at the Belgian coast.
Yeah. So before I start, it's pretty funny. So for me, like scientific conferences are kind of like baseball games. It's really interesting. You always want to go, but it gets kind of rough, especially if you're the last one. So what they invented was the seventh inning shake, and it's kind of just stand up dance. So maybe we do something similar. So who is not involved in the project, an algae project? I'm not directly involved. All right. And who is involved? Awesome. Can we just have a round of applause for the project? Because I think it's amazing. So that was our little shake. All right. So first of all, so I'm Benny. I work with eCoast, and we did a study commissioned by Flanders Maritime Cluster, looking at seaweeds that grow locally at the Belgian coast. I guess most of you don't know eCoast. We're a local player. So I'll quickly introduce us. We're a company. We mainly do, and we're an internationally operating marine research company, focusing on impact assessment, environmental monitoring, also legal and ecological aspects of maritime activities. Founded in 2009, we have 2 offices. We just expanded to the Netherlands, and the word that I'm proud to present was one that we acquired recently. And we're actually involved with a lot of research projects also around similar topics as an algae, like marine microorganisms, marine biotechnology, blue growth, the Maribel project, and integrated aquaculture in Flanders. All right, so off with the study. If you think about seaweeds, you wouldn't necessarily think about the Flemish coast. That's basically because we kind of have unfavorable natural conditions. So our beaches are kind of sandy and relatively steep, and we also have no protected areas, so such as bays where seaweeds like to occur. Our beaches are littered though with a whole bunch of different artificial structures, such as groins and breakwaters where seaweeds can develop. But overall, our beaches are just used for tourism, so we've got a very well-developed tourism industry. And a lot of studies kind of show that there's kind of a negative correlation between tourism and aquaculture, so that's kind of not such a good thing for us. But despite these seemingly unfavorable natural conditions, we do have a very strong aquaculture incentive here in Flanders. We have a lot of academic knowledge accumulated in Flanders. Recently, we also have a lot of projects where industry are involved, such as, for example, in algae, but also at sea and aqua value, where the goal is really to look at revamping aquaculture in Flanders. And that's kind of necessary because, 2015 is kind of a special year because we're celebrating 250 years of aquaculture. It started in 1765 with the growth of culturing of oysters. But unfortunately, despite a big boom in the 18th and 19th century, it kind of grew to a halt because of wars, disease, and pollution. But now, partly due to the Blue Growth Strategy of the EU, there is a renewed interest to start with aquaculture in Flanders. And in fact, we see that a lot of the companies starting recently, and I'm really mean recently, like last month and so, a lot of these technologies are based on land, but they're also very technology driven. So it's not aquaculture, we don't have a clean environment necessarily, so we can't do aquaculture. It's very technology driven, it's very forward looking. And so we started culturing kinds of sea bass, tropical shrimp, things you wouldn't necessarily expect in the region. Mariculture, we also have some trials in the North Sea, but right now we don't have any commercial operations presently. Now, going back to seaweeds, call us ambitious or stubborn, but we're considering growing seaweeds along the Belgian coast. And right now, seaweeds occur only in a few locations, and it's mostly focused around ports and estuaries, where you have these artificial substrates. And overall, we've got a limited biodiversity, so we only have 87 species, I believe. But even though there's only 85, we see that a lot of these native intertidal species that we do have some commercial interest. And then I'm mainly thinking about Oviporphyra and Fucus, where there's a lot of different applications in various parts of the industry. But even though we all know these seaweeds occur there, little is known about their nutritional composition or the chemical contaminants. So this is kind of where this study sets in. So there were two parts to our study. The first one was to look at seaweeds in Flanders in general, and then specifically look at those species that had applications. And then setting out on a sampling campaign to gather different kinds of seaweeds at locations. And so we focused on the port areas because that's where the artificial substrates are. And then looking at their chemical composition. In the second instance, we're already looking a little bit in the future. Imagine if we were to start culturing it. Can we locally process these seaweeds and dry them here? And what methods will we use? What protocols will we use? Where could we potentially have a pilot testing for such drying tests? So starting with the first part, what seaweeds do occur. So we chose to sample at two locations. One that's exposed to wave action. The other one that's a little bit better protected at the inner harbor. You can clearly see the zonation in both areas. So going from the green algae zone and the fucus zone. You can also have a big ulva band and porphyra band. It's not very special, even though it's kind of interesting to remind you with the protected side. We had pretty dense seaweed growth, especially in the fucus band, which was very pronounced actually. So at these two sites, we chose three samples and three species. So porphyra at one side, fucus at another, and then ulva at the waterline. These were all taken at the low water, and so low tide. And then we sent them off for analyses. The first thing I would like to look at is their nutritional composition, and it doesn't really show because I had anything. But overall, it was just ulva. So very standard compared to French nutritional composition. Very, very normal. Nothing special to remark. Ulva is a very low caloric value seaweed, only 35 per 100 grams. And as far as contaminants, we were only able to detect, of the regulated contaminants at least, only arsenic and lead, and still at relatively low levels. We also selected some others, such as cadmium, mercury, tin. We didn't detect any of them, even though the limits of detection were kind of low. As far as interesting compounds, polyphenols, mannitol, and iodine, we didn't find any in all, at least. As far as the contaminant levels, we were well below the EU limits, at least for food supplements, which are a little bit more tolerant than some other limitations. But overall, it looked kind of favorable for ulva. So good nutritional composition and all below the EU limits for food supplements. The second one was porphyra, which is a red seaweed. Again, very typical nutritional composition. Again, we found arsenic and lead. Arsenic was 3 to 4 times higher than ulva, so a little bit more accumulation, and it came from the same location as the ulva, so it accumulates a little bit more. And again, no cadmium, mercury, or tin, and none of the interesting other compounds such as polyphenols, mannitol, and iodine. Here also, well below the EU limits, so good for human consumption. And then the last sample that we took was fucus. Again, well within the normal range of fucus, just fucus. So we have a normal environment, a normal seaweed development. But this time, in addition to arsenic and lead, we also detected cadmium. We did find them at very, very low levels. And again, no tin or mercury. But we did find some mannitol. And normal fucus, so at exactly the same level as reported by producers in France. So just decent fucus. And again, contaminant levels, a little bit higher again, but well below EU limits. So on to the second part, where we looked into seaweed drying locally. We asked around, we contacted a number of industrial and academic experts working around seaweed cultivation or seaweed in Europe. We quickly found out that it's not easy once you start asking for how to process seaweed. It's proprietary. Nobody would like to give their trade secrets away. So maybe not surprised. But we asked really nicely, and we got some insights, not necessarily special. Basically, we just use the same drying techniques as the food industry uses. So rotary drum dryers, conveyor belts, some centrifuge, some press as a pre-treatment step. But nothing out of the ordinary there. As far as temperatures, they got really specific. Lower than 60 C, lower than 50 C. Not too high. There's a lot of studies also showing that you shouldn't dry with above 50 C, otherwise you get blackening, you lose a lot of antioxidant activity, which is an interesting feature of some seaweeds. And typically shorter drying times are preferred. Just because you lose the antioxidant activity. We also did a small test. We freeze-dried fucus, and we were able to decrease the moisture content from about 80% to 80%. Iodine was not detectable before, but it was now. Arsenic levels increased a little bit, same as cadmium and lead, but still well below the limits set by the EU. And we also looked at some pilot locations for potential future, if you want to set pilots for cultivation, try to get the ball rolling. And we found a whole bunch of pilot locations where drying installations are used routinely. Such smaller companies, for example, that process U clippings, which is something for the cancer pharmaceutical industry. You can easily start using it. Wood drying companies also that rent out their facilities in case you want to try it. And also, of course, universities or research facilities that either have lab scale or pilot scale facilities to dry the plants. So, everything looks favorable to try it. So we have seaweeds in Flanders, yay. Mostly occurring on artificial marsh surfaces, and some are commercially relevant. We have the typical nutritional composition, and all contaminant levels are well below the EU limits. There was a study previously, actually by some research institutes in Flanders, where they looked at mussels and other sea products, and there they did exceed the limits. So, seaweeds are good. And what was more, I compared with some other scientific reports, and compared to some other scientific reports in other regions of the world, we kind of have low levels of contaminants. So, favorable to start cultivation. As far as seaweed drying, as I said, even after you dry, we're still below European limits. But we're going to have to develop our drying protocols ourselves because nobody wants to give that away. And there are ample test locations available, so it doesn't just get going. So thank you very much.